Hello, everyone. My name is Kamesh Pemaraju here at Platform 9. Welcome to our very last webinar of this series. Good morning, good afternoon, good evening, wherever you're joining in today. Excited to kind of kick off this last webinar. We're going to really recap and summarize the Kubernetes Journey webinar series, which we have been having for the last 8 months or so. So we have assembled our panel of experts who are going to go through and present the best practices for each stage and type of Kubernetes deployment. So if you go to the next slide, Peter, we'll quickly obviously do the introductions. Some of these speakers may not be that unfamiliar to some of you who have attended some previous webinars. Peter, of course, has been our anchor throughout the series. And Chris and Rupak have been also joining us in the past few webinars. So like I said, we will summarize the key recommendations from our experts based on their vast experience in Kubernetes deployments and product development, etc. So if you go to the next slide, Peter. As always, we're going to do a giveaway. Again, we appreciate you joining us today. We have one free online Kubernetes course from our learning partner, LearnK8s, which we will announce at the end of this webinar, as we always do. And yeah, we will look forward to the session. Peter, if you could go ahead and kind of introduce yourselves, and I'm going to hand it over to you, Peter. And as usual, feel free to ask questions along the way. You can use the chat window or the Q&A button, and I'll be monitoring these questions. And as I see relevant questions to the discussion at hand, I'll bring them up. And of course, we'll have the final Q&A sessions towards the end of the webinar. Thanks again, and let's have a great webinar.
Great. Thanks for the introduction, Kamesh. Hi, everybody. My name is Peter Frey. I'm Field CTO here at Platform 9 Systems as well. What that means is I run our pre-sales teams and our customer success teams here. I'm presenting to you today from sunny Florida. I've been with Platform 9 for 3.5 years, and I've also been kind of hosting this webinar series of how to take Kubernetes and move it from a concept in your enterprise all the way into production. And so it's been a great 8 months of webinars, and this is our final one. So I'm looking forward to the rest of it. Who's next? Rupak, I think. Nope, Chris Jones.
Hey everyone, Chris Jones. I'm a group product manager here at Platform 9. I look after our Kubernetes platform. Been with the team for almost 2 years. Prior to Platform 9, I was also a product manager at Quest Software looking after a application performance management platform. So I've always sort of lived in the infrastructure and application space, and looking forward to hearing everyone's questions about how to get a production-ready clusters up and running and building out a standard environment for dev test as well.
Hi everyone, this is Rupak Parekh. I'm one of the founders as well as CTO at Platform 9. Deeply involved with Kubernetes since 2016, I think. And it has been a fantastic journey. Looking forward to sharing some of the work and some of the best practices that we have gathered over the years.
Great. So every one of the previous webinars, we started with what the enterprise journey looks like to Kubernetes. And today we're just going to give an abbreviated kind of view of this. And I'm just going to build this out. It's kind of building funny. Anyway, so I get a chance to talk to people every day as part of my role. I get to talk to people that are prospects of Platform 9, customers of Platform 9. I hear a lot of information on how they're moving down the path to Kubernetes in their organizations, right? And so these are the high level steps that it seems like everybody goes through. Well, how do I want to deploy my first cluster, right? Well, when I deploy my first cluster, is it in the cloud? Do I do it on VMs? Do I do it, on bare metal? Make some decisions. We Google how to do it. We get it up and running. And then the next sort of step is, well, I'm deploying Kubernetes, but what networking, what CNI should I use and why, right? And that's a decision you have to make. People start with Flannel or they start with something else. And then they realize, well, maybe I want policy isolation or network isolation between pods. And how do I do that? Oh, maybe I should have gone with Calico or something like that. So these are all steps in the journey that every excuse me, that every customer makes. And then as soon as they make that networking decision, now they're looking at storage, right? And what does that mean? So while cloud native apps and stateless apps are great, there's always that app that needs some form of persistent storage. And a lot of people want to run that in their Kubernetes cluster. So how do we do that? What are some of the best options for doing that? And they make some decisions and they do that. And this is all in that vein of that first Kubernetes cluster, but they're also making decisions for what their production environment is going to be. And then as we move through it, I like to include logging and monitoring together, right? And this is really an environment where, if we're in production, we've got to have logs. And what happens if I have a pod and it's logging, and then that pod crashes, but it doesn't start up on the same worker node in the Kubernetes cluster, and then it starts over here? How do I correlate those logs between those two different servers to know that it's the same application that's having problems just on a different worker node in the cluster? So that's another interesting topic. Monitoring becomes absolutely critical, right? We have to know that not only is Kubernetes functioning the way it should be, not only are the hosts not consuming 100% of memory and 100% CPU, but we also have to know that our applications are responding timely and that sort of thing. So monitoring you do it a little bit differently with Kubernetes, and we'll talk about some of those best practices here shortly. And then after you kind of get your Kubernetes cluster the way it deployed, and for this production application, now you start to think about, how do I do CI/CD? How do I continuously deploy? How do I do A/B deployments, right? How do I isolate one workload from another workload with a different set of users, right? With Kubernetes role-based access control. And a lot of this day two. And then how do I upgrade the cluster? What happens if etcd dies or loses quorum? What happens if I want to add another worker node or delete a worker node? Just all the DevOps kind of questions. And then, and then lastly is the day two stuff, is that the upgrade and maintenance and that sort of thing. So we're going to spend some time in today's webinar to talk to each one of these boxes. And we're just going to have a kind of a live discussion with myself and Chris and Rupat. So I think the first place is we wanted to jump in and talk a little bit about common use cases, or use cases that we're seeing across our customer base or our free tier customer base. And one of the first ones is machine learning. Chris, you want to highlight on that?
Yeah, I mean, this is one of those trends that are sort of coming up in the market. I know a lot of research organizations, universities, pharmaceuticals, genetic research, all move to containerize workloads, or at least move to high performance computing workloads and infrastructure. Changes with tooling like Singularity and the rise of Kubernetes, and it's becoming more popular. That change is actually forcing machine learning workloads onto Kubernetes, and it seems to be a trend that we're seeing a lot of within our users, within our free tier environment, is that a lot of people that are running these workloads are now on that path to, all right, how do I build a Kubernetes cluster? How do I run that, make it stable? And how do I then operationalize this to start running different workflows, different data processing, different levels of analysis on that data, and moving these apps that might have been on a fairly static HPC cluster, or just containerized applications running on dedicated infrastructure. How do we now orchestrate that on Kubernetes, offer that as a platform as a service, scale that within my organization as well? So we've seen a number of users come in, and their target is, right, I want to stand up something like Flight or Nextflow to be able to run and orchestrate my high performance computing and my machine learning data requirements and workloads.
Awesome. Yeah, and I'm seeing a whole bunch of other use cases, other different types of activities that our customers are deploying inside of these Kubernetes clusters, right? Several of our customers are using Kubernetes as a build infrastructure, right? Where developers are actually SSHing into pods to be able to do all of their development work and building, and then taking that and building pipelines for deployment of their apps, right? I see that in a couple of our customers. We have other customers that are deploying Kubernetes in their retail stores, and so they bootstrap it with booting the OS and then booting straight into a Kubernetes cluster and then having that push the in-store retail applications. Think video surveillance, think things like my streaming music player, think things like my point of sale devices talking to my credit card backend systems, all of that. So we're seeing a vast amount of different types of applications being run inside of Kubernetes. And then other customers, we've got 5G customers, and Rupak will talk to you about that in a minute. But even our CDN customers and people wanting to deploy Kubernetes at some form of an edge, whether it's the retail edge or the telco edge or the CDN edge, right? But the requirement is that they have low latency access to all the pods running inside the Kubernetes environment. What this means is really it's line speed access. So if I've got a 10 gig Ethernet environment and I need to be able to pass data in and out of that pod and get it processed inside that Kubernetes cluster very quickly, you have to do a bunch of very Linux level configurations to be able to enable SRIOV and DPD or DPDK inside of your Kubernetes cluster. And Platform 9's got a very elegant solution for that. And we'll talk a little bit more about that later. Rupak, did you want to talk about a little bit about 4G, 4 and 5G?
Absolutely. So for years, I thought the networking industry have just recently moved to virtualizations, and moving to containers would be a big ordeal. But it has been surprisingly how fast they have moved. And this is one of the most critical workloads that you can actually run on Kubernetes. It requires a pretty high uptime, so on and so forth. And Peter also spoke about some of the latency requirements that they have. And it's surprising, but pleasantly surprising to see all the workloads that really take my voice from my cell phone to you or the other end is now actually using Kubernetes, and specifically on the packet core, which means taking the packets from my cell phone to the internet and authorizing it and so on and so forth. So a lot of those workloads are also moving to Kubernetes. As well as some of the vendors I have seen, they're also transforming their existing telco applications to run on Kubernetes as well, just to make sure that they can take the advantage of Kubernetes distributed architecture and the resiliency that it provides with the scaling, with the high availability, and so on and so forth.
Yeah, Rupak, when I was doing a proof of concept with one of our customers a year and a half ago, maybe, it was in the 4G world, and we were deploying VMs in OpenStack, and the setup time alone to configure the OS, to set the LXGBE drivers for SRIOV, to set up dedicated cores for the OS, dedicated cores for VMs, making sure they're all along the same NUMA boundary. It took us almost 2 full weeks just to set up the environment to run the 4G packet core, and this is greatly changing in 5G. Can you talk about a little bit on how that's expedited these days?
Yeah, so Kubernetes has what we call as a very declarative system. So you declare where you want to be, and that system kind of creates that environment for you. And a lot of innovation has been done specifically at Platform 9, where we have taken that declaration and say you want these workloads to be running on these CPUs, or you want these NICs to be configured in a certain way. All of that you can really declare and let the system, essentially Platform 9 and Kubernetes, to handle those for you. And once you do it, your system would be ready in next maybe a couple of minutes, whatever time it takes to configure those systems, and you're done. And now you can actually run your applications, which is the most important thing.
Right. So Kubernetes is really streamlining their ability to deliver quickly, and providing a very high level of resilience.
Yep. One more thing I would like to mention, we spoke about build pipelines. So one of our customers, they actually use Kubernetes to, believe it or not, to make sure that their build workers. They are they're a technology company. They have a lot of compilation CI/CD pipelines going on. So what they do is they actually take the container image for, let's say, Golang or Java, and their build team just publishes those container images. And as soon as the build is fired up, a new worker, if you're using Jenkins, it's called slaves or worker nowadays, and they are fired up. They have the latest environment that you want, and it can scale. So you no longer need to statically configure how big your farm is. You can actually use the compute capacity that you have as much as you can or as little as you can. So it's fantastic to see all the use cases Kubernetes is so good at to find its usage in all these different kind of industry, from ML to mobile packet core, and obviously your favorite build pipelines.
Rupak, I have another question for you. If you were to peer into the crystal ball and look into the future, I know that virtualization and containerization is going to continue to live together for a long time. How are our customers going to be looking at that in the Kubernetes world in the future?
I think what's going to happen, apart from just the containerization and virtualization, Peter, you spoke about, I think the fact that everything can be declared and it can be realized once it's declared, I think that form of DevOps is going to really take over, which means you are going to be configuring your host systems, you are going to be configuring your operating system, you're going to be configuring your applications with that declarative semantics. And virtualization, as we are seeing now, both containers and virtual machines are actually running on Kubernetes. So the systems are going to converge, and you are going to see a kind of a converged architecture, not the converged architecture that we are familiar with, but a new kind of converged architecture where everything essentially comes together.
Yeah, containers and virtualization, I think, are going to live together for the foreseeable future, and people are going to look to solve that problem. All right, let's move on a little bit. So our next topic is starting down that path, down that journey around networking best practices. So I think we're going to talk to, is this you, Rupak, or is this Chris?
I can talk through that. So I wanted to give you a quick background on what are the different networking aspects of Kubernetes and what are the things that you need to think about. And it can be a little daunting. So I have a couple of slides just talk about what are the things that you should look at. So very first thing is what we call as pod networking, and I'm pretty sure you heard the word CNI, which is a technology so that you can bring in different kind of network plugins to your Kubernetes. And this has to do with how your pods connect to one another. And there are many technologies out there. The two that I mentioned, the three that I mentioned, are probably the most popular one. Flannel has been around for ages. That has been the de facto standard for running a small cluster. Calico in recent years has appeared to be the most feature-full CNI, and I would really recommend that. It has capabilities like making sure you have the security between the networks, but it also has interesting capabilities like BGP, which can help you in not the high performance computing that we talk about with the telco, but high performance computing enough for running high scale web applications. So do take a look at that. The other thing to consider is whether you need layer 2 or layer 3 networking. And most of the CNIs out there, they do look at layer 3. There are CNIs like OVS provides, which can give you layer 2. So if you have traditional workloads who want layer 2 kind of connectivity, so you may have to think carefully on which CNI to pick. On the public cloud, specifically if you're using EKS or AKS or GKE, they have their own networking options, so you can safely go with them. Or you want to run something like Calico on top of that, you can also do that. So there are different options depending upon what environment you have. In past, when you created Kubernetes cluster, let's go to the DNS. In past, when you created Kubernetes clusters, the internal DNS, so that one service can discover another service, or one pod can discover another service in the cluster, you would use an internal DNS system called a Cube DNS. But nowadays, we use Core DNS, which has become de facto standard for at least 1 year now. If you haven't moved, please do move. It has better performance. The other thing to note is, depending upon whom you are using, you may want to consider increasing the number of core DNS pods so that it can handle the load. But it depends upon your situation. On a very big cluster with a lot of pods, which is doing many lookups on DNS, you may have to increase that. So that's another thing to keep in mind. The next one is really service. So when you are when your pods are connecting to each other, they don't typically connect to each other directly. They connect through the internal services, which essentially act as load balancer, an internal load balancer for your Kubernetes. And that's where a component called as kubeproxy is used, which is not really a proxy. It is a fancy word for configuring IP tables or IPVS. IP tables is something that is used by default. It is well understood, easy to debug if you are managing your own cluster. But it may not work very well in a large cluster or a large number of when you have large number of services running on a cluster. So I would suggest use IPVS. It is not that well understood, though the technology has been around for ages. That is not very well understood, but it is definitely much higher performance than IP tables.
With Platform 9, do we use IP tables?
We used to, but we have switched to IPVS, and that's the default option. Same thing goes for core DNS, and even on the networking side, we use Calico by default. So we have all the best from what we can gather, so we can figure it by default.
And it's evolved over time. That's awesome. Rupak, I'd like to ask a question about Flannel, Calico, OVS, the CNIs. Do you find that customers are like wanting to deploy pods that maybe one pod's on VLAN 101 and another pod's on another VLAN? Is that kind of isolation a requirement for our customers these days?
Not at the VLAN level, but there are cases where you may want to secure one from another using network policies. So you may have, and it depends on the applications to applications, you may have a environment where you are serving, let's say, multiple customers. We have some MSP customers who may want to serve one namespace to one user, one customer, another namespace to another customer, and that's where the network policy can help you isolate the traffic.
So we can
and the visibility between them. Go ahead.
We can isolate pod traffic into a namespace to a set of users, and that I think that's applicable too, also to like a PCI use case, right? Where you might have a red zone which has got PCI data and needs to be isolated, and a green zone that's not PCI data, and any pods can access that.
And security in general, you want to make sure that you have defense in depth, so you have at multiple layers. You may want to restrict your database from being accessed by anyone, only one or two pods. So you are decreasing the surface area.
Yep, makes sense.
Yep. Okay, let's go to the next set of things on networking that you may have to think about. One of the big things that people come to us with is, hey, I have been running in public cloud with my Kubernetes cluster, and I can expose my services using a thing called a service type load balancer. So when you create a service in Kubernetes, you can expose it external to Kubernetes cluster by either node port, which means you are opening up a port, a non-standard port for everyone to talk to, which may work for development but not for production. So you may want to expose that outside of your cluster over a load balancer. So in public clouds, it's actually relatively easy. You have application load balancers or elastic load balancers that the public cloud integration provides, and you can expose your services to the outer world. But for when you're running on-prem on, let's say, VMware or OpenStack or just bare metal servers, how do you do that? So on-prem, Platform 9 comes out with Metal LB. It's a great option. It has multiple levels or multiple ways in which you can configure it. You can use L2 level load balancers, or you can do L3 with BGP, which is obviously the high performance aspect, but it doesn't mean that your networking setup is configured in a way that it can work with the BGP setup that Metal LB has. So those are some of the options that you can think about. Platform 9 obviously comes up with MetalLB by default, and specifically on-prem, where you can just configure it, and whenever you say in your application, I want a service type load balancer, we'll give it an IP, and you're able to access your application outside of the cluster.
Rupak, as a sort of a best practice when you're thinking about load balancers, do you see our customers or the people that you talk to still using external load balancers, or is this now kind of moved all the way into the Kubernetes cluster and stays there?
We have seen some customers still stick to the external load balancers, but specifically with a BGP, it's less and less important. And I'm seeing more and more customers using the load balancers that come out with Kubernetes itself.
Okay.
There might be some cases where you may have to do it, specifically if you're trying to do across clusters and so on and so forth, but those are pretty rare.
Certainly.
Yeah. Once you have the load balancers, you may not want to have every endpoint that you want to expose to have a load balancer as a service. And at Platform 9, we don't do that. So the next big thing that you should think about is what kind of ingress you want. Specifically, and this is essentially all the new applications that we are writing these days, they use HTTP or HTTPS. So when it comes into your cluster, you may want to say, you know what, that DNS name / service 1 should go to this particular microservice / service 2 should go to this microservice, so on and so forth. And that's where Ingress really comes into picture. And there are multiple options there. I didn't mention it here, but there is Nginx. All of us are very familiar with Nginx. Now it is being packaged as an Ingress, so there is some familiarity to it. But there are also lighter weight and some pretty interesting Ingress controllers like Trafic that you might want to look at. And it will all come down to your familiarity versus some of the features. Functions are slightly different between those two. So you may want to look at those. One of the ones that we use is, we actually use an Ingress based upon SNI. So we can distinguish the traffic based upon the domain name. So you can say customer1.platform9.net and customer2.platform9.net, and we take the traffic. The traffic goes to different services and pods depending upon that. So that's another option that you can use. Apart from the standard networking practices for enterprise, Peter spoke about low latency services earlier. And so we do have a lot of advanced networking. Peter spoke about, hey, can I have a pod where you want to have VLAN 1, VLAN 2 can talk to the same pod? By default, it doesn't work. You cannot have one pod, cannot have multiple networks. And there are other features like that. So Platform 9, we have advanced networking enabled in our product, where you can have multiple networks using Multus. If you're running on public cloud, you can have MAC VLAN or IP VLAN, kind of features for high performance. And if you're going further, specifically on hardware, you can use something like SRI and DPDK or IPv6 if you're looking for IPv6. That's also available now. Dual stack is still in beta in Kubernetes, but I expect it to be GA sometime later this year, but we will see that. And if you are interested in this, specifically in this particular part, check out Platform 9's Luigi. It's available. If you search on Platform 9 docs, you will find it. It has support for everything that I mentioned. I mentioned here. Anything else to add, Peter?
Nope. Let's move on to the next topic. And this is about storage. So you've got your Kubernetes cluster, you've deployed it with your networking, you're feeling pretty good about it. And then you have that app that needs persistent storage. And I think Chris is going to talk to us about what that looks like and means.
Indeed, I think this is one of the areas where a lot of users early in the journey get stumped. I think it's somewhere that the Kubernetes platform and Kubernetes itself has evolved quite well. I think the first big change that people have been using Kubernetes for a while have seen is the shift to the CSI driver model for provisioning storage. When I started learning Kubernetes myself, started looking at CSI drivers and other ways of provisioning storage, I naturally gravitated towards this going straight to the CSI drivers. It looked like the future. And for those of you that weren't aware of the change and what CSI introduced, it basically, the Kubernetes community decided that storage should be something that is almost templated, and it comes with a best practices for storage vendors to leverage, versus being something that was built into the core platform and revisioned with each release. So the CSI driver approach has enabled all of the storage vendors out there, and that storage vendors that have been born in the cloud and are more hyper-converged, all the way through to the traditional Dell EMC type storage that's out there as well. It's enabled them to build and revision their own storage plugins, CSI drivers, outside of the Kubernetes release cycle. So it's really introduced a lot more stability and speed and flexibility into the model. When someone's looking at the Kubernetes infrastructure and they say, well, what should we do for storage? We've got a virtualization platform today, and we have, let's say, pure storage running. Should we continue using that now for all of our clusters, or should we evolve to use something else different because we're going cloud native now? I think one of the pieces to look at is, where do you plan on running your applications today and into the future? I think that's a really important discussion from an application architecture perspective, but also from a fundamentals for your infrastructure. If you know that you're going to be running across multiple clouds, or even just hybrid from a colo or your own data center and into a cloud, I think it's important to really to learn about and investigate different storage platforms that can give you consistency across both of those environments. So if you're thinking, well, what would that look or sound like? Maybe something like a Portworx would be a tool that would enable some consistency across those clouds and environments. I think another important consideration is across your environments for building, testing, and running your applications. So, a lot of the elements we've been talking to early with the use cases we're seeing for Kubernetes. We're talking about declarative approaches to operating in the cluster itself. That base infrastructure, which is storage, the CSI drivers, your storage classes, persistent volume claims, all these pieces need to be consistent and the same across environments. If you have people changing something to make it work in a lower environment, when you promote that code to production, you're not necessarily going to get success. So I think it's important to really aim to have a consistent environment and make sure that you're using identical patterns. And if you're not using identical patterns across all of those environments, to make sure that that's something that is captured, and that is something that is version and controlled, and everyone understands what that means. I think it comes into a lot of forefront with performance testing as well. If your applications are using a lot of back-end data. The third piece, and this is somewhere I think the industry is slowly evolving to, and I guess learning more and more as everyone's sort of getting applications running on Kubernetes, is data protection. Right? Today, all of the backup vendors, they know how to protect a physical machine. They know how to protect a virtual machine. They know how to leverage different APIs and those hypervisors to create different backup strategies and recovery windows, your RTOs and RPOs. When you move into Kubernetes, you're in a whole new world, right? If you're completely stateless, then what does data protection mean, right? Is it all just infrastructure as code, right? Can you capture that known state? And if there's a problem, you just redeploy and it's recovered from a sense of your user's experience. When you start moving into applications that have stateful workloads, do concepts like application-aware backups come into consideration. That's one of the newest topics of discussion in the world of data protection and Kubernetes today. I don't think the industry or the projects around Kubernetes really have solutions for that right now, but it's what the backup vendors are really looking at and trying to solve for. And And I think it's important that anyone that's considering moving to Kubernetes with stateful workloads, I think data protection should be considered upfront. What is the strategy for recovery? What happens if data that's been used in production is altered in some way that's not correct? So I think they're the three big buckets that people should be looking at and considering as they're moving to build out their production Kubernetes environments.
So Chris, I was talking to one of our prospects this morning, a couple hours ago, and they are a medical records company, and data is key for them. If they're planning and looking into the future, and Kubernetes is that future for them, what would you recommend for a CSI or an implementation when the data is that critical? And it might be on your next slide here too. So,
yeah, I think we should go to the next slide just so people can sort of see a little bit more about what's going on in the world of storage. I mean, data integrity is a big piece of that. I once, had the pleasure of launching and building a software-defined secondary storage platform that deduplicates data, backup data specifically. And data integrity is a really big consideration that needs to be taken into account with any data. Medical records is another really sensitive area of that. And I don't think Kubernetes is really solving that problem for users. That's still a core infrastructure problem. How do I have a highly available and resilient storage backend? And how do I make that available to all of my workloads? If I was in that conversation this morning, Peter, I would be asking around, well, what do you use in your infrastructure today that gives you that array level or filer level consistency, depending on the architecture of the application and the physical environment they're using today? And I would say go and look and see if there's a CSI driver that supports that. I would be shocked if they were on a storage device that didn't have the support for CSI. There's a site out there. If you just Google Kubernetes CSI drivers, you're going to get that full list.
Yeah, so they were specifically like looking at a storage vendor, a SAN, right? And there are drivers for Kubernetes, but they're looking to get away from that. And so they were looking at Ceph and some other things. And I just thought our community might like to know, what's something that's solid that works? What do we recommend, or what do we see our customers use?
Yeah, Rook Ceph, I personally find is incredibly easy to get up and running. And stable, and Ceph, there's many vendors out there that will help you support that as well. So I think that's a great cloud native as well as a sort of hyper-converged approach to delivering storage to a cluster. I think if you're looking to learn and get going fast, it's a great way to start as well. You can get that up and running on a single node cluster or a really small cluster, and then work with the community or work with a Ceph vendor and leverage Rook to scale that out. There's also OpenEBS and Maya Data are another great example of being able to do that in lower environments using OpenEBS, and then maybe moving into Maya Data and stuff like that as you move to production and want to scale. Another great platform that we partner with and we work with, and I personally use in clusters that I operate, is Portworx. They really do provide a great enterprise grade product. They're thinking about backup and recovery as well. They work on multi-cloud and hybrid cloud deployments as well. So that's that future thought. How do I get from where I am today to a multi-cloud or hybrid cloud position? They were recently brought into the Pure Storage team, who we collaborate with today. Each release, we sort of work to make sure that everything's working, that CSI drivers are operating as expected on Platform 9 Kubernetes. So I think there's some of the options that we've used internally and work with and document on our own doc sites as well, that people can get going, that are great for production and great for learning as well.
Fabulous. Any other thoughts as we think to wrap up our storage section?
No, I think I've touched on everything that I was looking to touch on and share with the community.
Great. So next we'll talk a little bit about logging and monitoring and some best practices there. Rupak, jump right in.
Sure. So having been in the infrastructure space, all of us have moved from bare metal machines or virtual machines to containers and microservices, or microservices and container rather. I call them pets and cattles for obvious reasons. And so in the virtual machine era, we were treating virtual machines same as bare metal servers. We would take care of them, feed them every day. Log aggregation was really a luxury for most companies, as well as monitoring was there, but sufficient monitoring could be provided by just running some tools on that virtual machine or on that server, unless and until you were running like thousands of machines. And so people still did the things the old way. With microservices specifically, and containers just accelerated that has completely changed. We have hundreds and thousands of containers running now. And even for a small applications, because it's divided into microservices, for even a small application, there are tens of 20s of containers multiplied by obviously the scale. And those containers are immutable. The logs will disappear as soon as your container crashes, or maybe soon after. The monitoring aspects have also changed. So instead of doing profiling of the code, that's what developers used to do. Now they want to understand how the connections between their applications to database or connections between their applications to RabbitMQ is working. And so that has changed the way in which we operate. Log aggregation is no longer a luxury. We need to collect them in central place because we have so many objects that we're dealing with. Correlating them is not easy. So we absolutely have to collect them in one place and then do the analysis. Similarly, for monitoring, you not only have to do the system monitoring, which is important, but also make sure that you're able to do a macro level monitoring, tracing, for example, between calls between different microservices, and that is really, really important. So with that, let me jump into what are the ways in which you can enable monitoring for your applications and even for your system. Next slide, Peter. So on logging side, there are there are hundreds of options, I guess. I have listed some of them here, but this is no longer, this is not exhaustive. So when you're thinking about log aggregation, you can obviously go with commercial, self-hosted, or cloud-hosted options. Splunk is a fantastic tool. Elastic Cloud is fantastic. We have used Elastic internally. We have used Sumo Logic in past. We have used some other tools in past, and they're all great. It really depends upon how much data you are producing, and how much data you want to index. So there are things that you need to play around with, because because the cost can quickly spiral up. Whether it's self-hosted or commercial hosted, the amount of data that these applications log these days is just enormous. There are a few open source options that I would highlight on the logging side. Elastic is obviously the most the prominent one, and that does the actual logging collection and indexing. But we also have Fluent D or Fluent Bit, which, for example, Platform 9 ships with. So you can actually connect to any of the log aggregation systems. If you are thinking about Fluent D or Fluent Bit, my suggestion is to use Fluent Bit. It's much more performant, and it works with almost all the log aggregation system. There is another entrant that that I thought was pretty interesting. It's called Loki, which is from the same folks who did Grafana. It's from Grafana Labs, and it's built on a similar architecture to Cortex, and we'll talk about that in a second. So that is essentially what the logging systems would cover. But there are some vendors which will cover both logging and monitoring, and I will come to that in a second. The other aspects of your application is going to be really how do you monitor your application which is running on Kubernetes. And again, there are many commercial vendors that provide Kubernetes specific monitoring and application level monitoring as well. Datadog, Dynatrace, Sysdig are few that I know of. but I'm pretty sure there are many more that I'm missing. At Platform 9, we focus a lot on open source. And what we have done is we ship out with Prometheus. So when you are creating Kubernetes, we know how important it is to have a monitoring system available so you can do one check, Prometheus installation. And that works out great. Every system that I know nowadays, or almost every system that we know nowadays, is compliant with Kubernetes. So they have these exporters, which you can really direct your Prometheus to talk to, and all those metrics are imported into your Prometheus server. If you are looking for something more complicated, if you are multiple tenants or you have really large amount of data, Prometheus has other projects. One that we use is called Cortex, which can do multi-tenancy on top of Prometheus, and it can also scale out very well. And it uses a bunch of other backends. So do take a look at that. One thing that, yeah, go ahead.
There's a quick question here. I think someone is asking about double-clicking into the benefits of Dynatrace or Sysdig, if you have anything more to add there.
They are very similar. Sysdig has been around for some time, and so is Dynatrace. Sysdig actually started with their very interesting kernel module. So they used to have this small utility that you can run specifically for containers. So they started with that, but they are, in my opinion, largely equivalent. Moving on. Yeah, go ahead.
If you were gonna think about logging and monitoring, right? Monitoring is critical because I want to know when my pod crashes. And as soon as I'm done with knowing that pod crashes and it gets restarted, maybe on a different worker node, then I'm going to want to know about logs, right?
Yep.
And so if you were, and you've lived this life, you've developed products here at Platform 9, we've developed monitoring systems here at Platform 9, you've made decisions, you've tried different things. What would you recommend a good place to start for the people on the webinar, if they had to pick something and do it very quickly just to get up and running, or maybe they're down the path a little bit, what would you say for logging and what would you say for monitoring are kind of like the premier places to at least get started before they go into maybe a paid solution?
If you guys are looking for open source, I think you should pick Prometheus. As I said, this is pretty standard. It works very well. And as I said, we already provided out of box for monitoring. For logging, FluentBit with Elastic would be a good start. Elastic is available specifically for small scale. You can deploy it on the cluster itself. It's part of the most application catalog, and there are multiple applications, Helm applications available for Elastic, starting from one node to multiple node clusters. So those are the two that I would start with.
And when you say Prometheus, you actually mean Prometheus, Grafana, and Alert Manager. Is that right?
Yes, thank you. Thanks for clarifying that. That's very true. So Grafana is, like you said, is the UI associated with it, and Prometheus is the actual backend. So by default, Prometheus itself, the UI is not that great. Grafana is definitely recommended.
The question on New Relic is there anything you want to add on New Relic?
Let me talk about the tracing because I was coming to that. Okay. So, and it's not very obvious to folks who are running Kubernetes, but application developers actually, for myself, when I'm looking at many microservices, it's important for me to understand what is the performance profile when one microservice talks to another, and then it talks to another, and that goes to the database. So it's like a long chain of events because now we have divided the application into small pieces, and that's where tracing really comes into picture. So Jaeger is one that we have used, which is open source. So I would recommend that. The other one is New Relic, and AppDynamics are a few others, APM tools. All of them are fantastic, by the way. But if you're looking for open source, Jaeger is the one that is very popular. But New Relic is pretty good. AppDynamics is pretty good. You can use any of those.
I've used New Relic in the past, and doing synthetic transactions and being able to trace it through all the different components from the web front end to the back end and all the way back up, and seeing latencies at every point in that communication was critical. In fact, we were able to debug right down into the database, finding one table that didn't have an index on it. And as soon as we put the index on it, the latency went, to almost zero. So fabulous tools for monitoring, I think.
Yep. One other thing to consider is if you want to have multiple systems or you want one system. So nowadays, and both commercial and open source, they are trying to combine logging and monitoring into one system. So for example, Elastic, ELK stack, I know they are well known for logging, but I have seen even monitoring capabilities from them. Similarly, from the Prometheus ecosystem, they have a system called as Loki, which can be used for logging, as well as the commercial ones like Datadog, Sumo. All of them have both monitoring and logging solutions. And the advantage of that is to what Peter you spoke about earlier. You want to pinpoint you want to find the problem using monitoring, and then debug it using the logging framework that you have. So having all of them in one place helps you with that analysis, and that's going to be very critical for your application developers, as well as if you're running everything by yourself and on Kubernetes and the system themselves. I think it will be very critical for you to have that kind of correlation between those two dimensions.
Absolutely. So we're running up close to the top of the hour, Rupak. Any final thoughts on logging and monitoring?
No, I think we covered it pretty well.
All right, thank you. DevOps trends and best practices. Chris, talk to us about that. What does that mean?
I think we could all spend hours talking on the previous topic and this topic as well.
For sure.
I think as a business, Platform 9 tries to, obviously we run a DevOps team, we run a SaaS platform. When we're talking to users from our free platform all the way through to enterprise, it's what works in your organization today, and let's integrate with that. And I think that it's such a huge portion of operating, especially a Kubernetes environment over sort of a traditional virtualization platform, that it's important to consider what's working. If you don't have CI/CD tooling and you're moving to Kubernetes, then take a wholesale look at where you're going to be running, what works in that particular environment. If you're going to be cloud only, then look for something that fits well for that. If you're going to be on premises, one of the use cases that was discussed was build platforms. What's going to work to enable that to happen as well, right? So there's many as a service options, there's many run it yourself options, and there's, I think, some great open source tooling out there as well. If you're just getting started, maybe looking at Helm as a package managing system or a package manager. If you want self-service, is another great way to enable developers to, maybe leverage a container as a service platform or a Kubernetes as a service platform that you're offering to them, so they can go and deploy their own applications as a standard within your organization as well. Push or pull, I think GitOps is getting a lot of attention right now, and I think we're going to see a lot of fluctuations and changes within that environment. And it's all about maintaining a known state. And I sort of touched on it earlier with drift and dev and test environments. There's so many knobs and whistles that can be changed within a Kubernetes cluster. And if people have that ability within their RBAC profiles, and they're deploying applications and like, well, let's go and change this configuration, or let's change a security policy, for instance, for two pods to talk to each other. It's important that drift and change is captured, right? So, I mean, DevOps is so huge that you need to understand how do you maintain a known and steady state, and make sure that what is happening in development, if it involves a fundamental change on that Kubernetes infrastructure, that is promoted the whole way through to production. Because you can really hit roadblocks and spend hours and hours trying to figure out what's not working in your environment. The last piece that's on here is, what about your infrastructure? One of the pieces that we're looking at and investing in today as a future roadmap item is being able to capture both the cluster's state itself. So how are we setting that up? How to templatize that? How to make sure that every cluster is exactly the same as it's deployed? And not just focusing on that moving up into the next layer. So your security policies, your RBAC configurations, and then, making sure it's consistent. So that push or pull technology as well. Just aware of time, so I think we're going to continue on to the next few slides here. Hopefully that provided some insights for people. I know it's not really saying, go do A. I think what we really want you to take away is there's a lot here. If you feel overwhelmed, you're not alone, but really do consider what's working today in your environment and create a roadmap and a plan and start executing towards it.
Great, thanks, Chris. I'll wrap up on a 1 minute of day 2 operations and best practices, right? And really, this is going to be a bit of a commercial for Platform 9, but I think it's really what people want to see, right? They want upstream Kubernetes, right? And Platform 9 delivers that as a SaaS managed service. We have monitoring and automation, right? So anything that we deploy, we monitor, right? And the beauty about that is Platform 9's got your back in managing your Kubernetes clusters. And we've got this team of experts. I don't know how many certified Kubernetes administrators that we have on staff now, but I think it's in the 20s, and growing every month, right? And when we have a problem with Kubernetes, our support teams, we've been there, we've done that, we've seen that, right? And we bring that expertise to your Kubernetes clusters, allowing you to manage Kubernetes clusters without having to worry about Kubernetes, just worry about the apps that are running on top of it. Okay, so we've got full automation, right? We have APIs for deployment and management and monitoring and maintenance upgrades. I'd say we've got one of the simplest zero-touch Kubernetes upgrades in the industry, where you can use our UI or our API to upgrade a Kubernetes cluster. It works great, and it's tested by Platform 9 before it's released to our customers, right? We're going to be able to deploy Kubernetes where you want to deploy them, whether it's in AWS or on bare metal or on VMs in the data center on the East Coast and data center on the West Coast. It's fully distributed. We can do that. And all of these Kubernetes clusters that we deploy have a financially backed SLA, right? We are part of the Kubernetes Security SIG, special interest group, allowing you to, allowing Platform 9 to get vulnerabilities from the Kubernetes API and from that team before they're released to the public, allowing us to work with them to create a patch. And then we can push that patch to the Platform 9 managed Kubernetes offering, right? And we are PCI compliant. So that's my 1 minute on Platform 9. And I think with the time left, I think we should jump right to commercials or commercials, questions and answers.
Yeah, one quick question. Somebody just asked that they're just starting to learn about Kubernetes, and great session on what it takes to go into production. But if you're just getting started, what is your advice and how do we get started?
So I'll jump in and maybe I'll let the other guys answer as well. But the Platform 9 free tier, it's there, it's available. You can use it with your own infrastructure, and you can deploy a Kubernetes cluster. You can see just how easily and quickly, without any assistance from outside help, how quickly I can deploy a Kubernetes cluster, right? And that's the first step. And then that also brings with it all this automation and Platform 9 experience, right? We make selecting that CSI very simple. We make selecting the CNI very simple, right? We give you tutorials on our website on how to deploy your first applications to that environment. So I think free tier is a great spot to start. Rupak or Chris, do you have any other thoughts?
I tried to build a cluster from scratch once. I would advise that's not a great place to learn. We have our free tier. There are other things out there that can really help you get clusters up and running fast, and I use those. It's going to save you from a world of pain.
Great.
Load balancing and storage are my next two things. If you're going to use Helm because you just want to deploy some apps just to experience, what does that look like? I want to use some tracing and stuff like that, and how do I access logs? Solving those two problems is also another barrier to entry and learning. Clouds will simplify that. Our free tier will also help try to simplify that. But if you're going to build a cluster and then deploy apps, make sure you understand the service type load balancer that could be used in that Helm package, as well as a requirement for persistent storage or storage classes as well. So there are two pieces to learn and research.
Yeah, thanks, Chris. We're at the top of the hour. Just wanted to announce the lucky winner for the free Learn K8s course. It's Prabjot Brar from Rakuten. Congratulations. We'll reach out to you soon with your free offer. Again, I'd like to thank everyone for joining us live today and thank the panelists for a very enlightening conversation. You will get a recording of this available on our website, so please go check it out. Also, the entire series is available on our website. So thanks again, and we'll see you soon in another webinar series in the future.